All right, so you should be seeing the screen. So I'm going to get started with what we have planned for today. Now, you would remember us looking at vectors. And we look at how to identify the magnitude of a vector and those type of things. We would have looked at vector algebra. What else we did in vector? Somebody help me. All right, no respond. All right, so the point is the earlier part of vectors, we would have spent some time looking at that. And it's just for us in terms of, you know, going back to and paying attention to some of the other key details for vectors. And one of them that we're going to be looking at in our session today is 3D vectors. So 3D vectors, so we are commonly used to vectors in terms of x and y, right? X and the y axis, and in the direction of x you have I, and in the direction of y you have j. But there is also k, right? So there's also k. And then you will see normally in a for the purpose of representation in a book, you'll see them have it represented like what you see yourself on screen there. And that is how you would normally see a 3D vector being represented. All right. And then like what we did when we were looking at vectors, where we look at the magnitude of a vector and those different type of things, the same principle applies here, because likewise we'll be finding the magnitude of vector, we'll be finding the um we'll be working in with vectors in terms of doing calculations. So nothing changes when working with the vectors in 3D. Give me a second, let me bring up something for you guys. All right, yes. Let us go through this and make some sense of, as we mentioned, vectors in 3D. So we know that is a vector has both magnitude and direction. So a vector quantity has both magnitude and direction. And we know that a position vector is a vector that starts from the origin, right? So you will note a position vector being represented with the symbol OP or OQ or something like that. Now, so representing a 3D vector in component form, you can have a vector like, say, vector P is equal to X, Y, and Z, right? Or maybe you have somebody say use it as ABC. But what we're going to have and recognize is that we're going to have three numbers instead of two. When we started out looking at vectors, we would have looked at a vector, so say for example, vector A, and it's equal to 1, -3. So we know that the top number is the direction of the vector in terms of X. The bottom number is the direction of the vector in terms of Y, right? So when you have it in 3D X, Y, and Z, it is the direction of the vector in terms of the different axes, all right? And it is not uncommon to find them represented like this. So you will see it represented in 3D as Z, X, no, ZYX, right? So it's not uncommon to see it represented like that, all right? So just pointing out the different representations that you can see the 3D vector represented in. So what we're going to do, we're going to look at a few calculations that has to do with 3D vectors and, just work through a few questions and see what we end up with for our solution. So we're going to look at adding, subtracting, multiplying, and stuff like that. All right, let's go. So right here and then we do an addition, subtraction, scalar multiplication with addition for these three subparts to the question. So the solution for A, where we have OA plus OB, is going to be equal to vector OA, which is 2, 1, 3, plus vector OB, which is -1, 2, 1, 4. So we add the corresponding numbers. So the two at the top, the two in the middle, the two at the bottom. So 2 plus -1, that's 1. 1 plus 2, that's 3. 3 plus 4, that's 7. So the resultant vector, which is OA plus OB, right? So the result here, this is called a resultant vector. We would have looked at this already. Right? So the resultant vector is 1, 3, 7. OB minus OA, that's going to be equal to vector OB, which is negative 1, 2, 4, minus vector A, which is 2, 1, 3. Negative 1 minus 2, negative 3, 2 minus 1, that's 1, 4 minus 3, that's 1. So the resultant vector of for OB minus OA is going to be equal to negative 3, 1, 1. Try the third part for me, please. All right, let's see what we end up with. It's 2 times OA plus 3 times OB. That's going to be equal to 2 times OA, which is 2, 1, 3, plus 3 times OB, which is negative 1, 2, 4. So 2 times 2 is 4, 2 times 1, 2, 2 times 3 is 6, plus 3 times negative 1, negative 3, 3 times 2 is 6, 3 times 4, 12. And then we just go ahead and add the results. 4 plus negative 3, that's 1, 2 plus 6, that's 8, 6 plus 12, that's 18. So this is the result of the vector addition 2A plus 3 times OB. So that would be the result. Look and see if there's anything I need to clarify before we have to continue.
It's pretty simple so far.
Okay, all right.
Uh,
Yeah, mix with the end of the day. Okay.
All right, let's look at it. You should be finished writing. So this so if we're going from A to B, now which point do they have in common? OA and OB. Which location or which point do they have in common?
Two, sir.
No.
Oh.
All right, look at OA and OB. What about them do you see that is similar?
They're both.
They're both what?
They both have 3 points.
All right, so they both have three elements or 3 points. Okay. All right, so do we recognize that both of them are position vectors?
Yeah.
How do we know that?
They start with O,
Start with O, meaning they start from where?
the origin.
Okay, so both points share the origin. Both points start from the origin. So they have the origin in common. So if I want to get from A to B, how would I move from A to B?
Go to A, O, and then OB.
So we're going to have to go from A to O and then from O to B. All right. So A to O is going in the opposite direction of the vector because please note AO is opposite to OA. All right. So A to O is opposite to OA. So that means once we're going in the opposite direction of the vector, what do you have to do?
Do the invert the values.
No. Think about it. So I was saying once you're going in the opposite direction of the vector, what do you do with the vector?
So you don't make them negatives?
That's right. You take the negative of the vector.
Yeah, that's what I mean by invert.
The if it's maybe if you had said opposite, then maybe I could have lived through that because the opposite of the positive is the negative, but the inverting of something, remember once you invert is to like you're flipping something, right?
All right.
So and notice is different from saying inverse because inverse we find inverse of functions. So this is going to be -2, -1, -3, and then plus OB, which is going to be -2 to so this is going to be -2 plus -2, that's going to give us -4, -1 plus 2, that's 1, -3 plus 4, 1. All right. So that's AB. Sorry. And now we need to go ahead and find the magnitude of it, which is just going to be equal to x squared plus y squared plus k squared or z squared or whatever letter they use. So we know that AB is -4, 1, 1. So it's going to be the square root of -4 squared plus 1 squared plus 1 squared. So it's going to be equal to 16 plus 1 plus 1, which is going to be the square root of 18. So you can leave it as the square root of 18 units, or you can just use a calculator. Well, you're in the exam and you have a calculator. You can just put in the square root of 16, what you get, 4 point. All right. Remember, you have to practice to use a calculator for these things. So it's 4.24 units to 2 decimal places. So that would be the length of the vector. Remember, the magnitude of the vector is simply making reference to the length or the size of the vector, all right? Bear that in mind. So in terms of I, J, and K, I'm just going to do one of them, and then you are going to do the rest. So this is going to be equal to 3I plus 2J plus K, or 1K. So if you write 1K, it's still the same thing. So K or 1K. Still not working. All right, give the other two a try, please. Let me see what you come up with.
Sir. Sir.
Go ahead.
Can you scroll up for me, please? All right, thank you.
Okay. All right, did we get these answers right here? Question 3,
Wait.
part B and C. You
Wait,
got those
what?
answers?
Um, yeah, for B, yes, but for C, but
Because it's zero.
Yeah.
yeah, but it's in the J part, it's zero, so for the two
Yeah.
end up on J.
So you say 0J?
No, I have five I minus two K.
Oh, K. Sorry. Mercy. Sorry. I made the error.
All right.
And this eraser look like it not working. So it should be K. So let's make that correction. Because the J is times 0, and anything times 0 is 0. All right, so we're looking at scalar dot product, and it is just how we multiply the matrix. All right, so without going through the question with you or the example with you first, I'm going to ask you to find what is U times V. Go ahead, please. All right, so we're going to get 2I plus 3j plus k. And we're going to multiply that by I minus 3j plus 5k. So we're going to have 2I times I plus 3j times negative 3j plus 5k times k. Right? So we know this little group doing their thing multiplying, this little group doing their thing multiplying, and likewise for that little group. Did we reach thus far when we were doing our calculations?
No, sir.
Yes, sir.
All right, so one of the things that we need to know is that I times I is equal to 1, j times j is equal to 1, and k times k is equal to 1. So this is going to give you 2I squared, which is the same thing as I times I. So this is saying, so this is basically saying 2, because I times I is going to give you 1. So this is going to be 2, and then this is going to be negative 9 plus 5. All right. So this is going to be 2 plus 5, that's 7 minus 9. That's going to give us negative 2 for our answer.
Did you see why?
Go again?
See why? Sir, why did you remove the I, J, and K?
Because them times I
When
times
you
I is 1.
multiply, I times I is equal to 1.
Okay,
Interesting.
okay. So, sure.
If they're equal to 1, then where'd they go?
Oh,
Anything
It
multiplied
times-
by 1 equal to itself.
Oh, right.
Okay.
2 times 1. Okay,
Yeah.
all right. I have it. On what?
Give this one a try, please. All right, let's see if we're on the same track. We're going to have
Sir,
two. Yeah,
sir, give us a second. Give us a second.
okay.
All right, sir, go ahead.
Work you, sir, work you. Yes, sir. Oh,
All right, not a problem. So 2 times -1, -2, plus 2x plus x minus 3 equals to 10. -2, -5, that's going to be on these two. So we're going to get 3x minus 5 is equal to 15. 3x is equal to 15 plus 5. Sorry. You know what I did? I'd start doing the calculation already. So 3x is equal to 15, divide by 3, divide by 3. So x is equal to 5. You got that?
Yeah, that's what I got, sir.
Okay, that's wonderful.
What?
Oh, that's from there. I
So cos of theta is going to be equal to the vector u times, well, I use b. I did say b, I didn't use v. So this will have to change to a b. And I don't know why the eraser not working. So let's look at what this looks like in a question. So I'm going to go through this one and then I'm going to give you one for you to try for yourself. All right, so firstly, we know that it's a product of the vectors, which is going to be 3 times 1 plus 2 times 1 plus -1 times 0. So this is going to give us 3 plus 2 plus 0. So this is just going to be equal to 5. And then we take the magnitude of each vector. So the magnitude of this vector is just going to be the root of 3 squared plus 2 squared plus negative 1 squared. So this is going to be the root of 9 plus 4 plus 1. So this is going to be equal to the root of 14. I'm going to leave it as root 14 for now, not writing the decimal yet. And this is also going to be the root of 1 squared plus 1 squared plus 0 squared. I'm just going to write this as the root of 1 plus 1 plus 0, which is just root 2 for now. I'm not writing a decimal as it. So to find the angle, it's going to be cos of theta is equal to the product of the two vectors, which is 5, divided by the magnitude of the vectors, which is going to be the modulus of root 14. Well, it's just root 14 because we do the modulus already. So root 14 times root 2. There's a rule in CERN that says if you have root A times root A, I think we look at this in indices as well. It's just A. But if you have root A times the root of B, it's equal to the root of AB, which means that in this case, you just multiply the two things. A times B give you AB. So if you have 14 times 2, this is just simply going to give you 5 over the root of 28. All right. What does this give us? Cos. Well, when you're finding the angle, is going to be the inverse, cos inverse of 5 over the root of 28. So
Sir,
go ahead.
yeah, could you put the symbols next to those equations? You know, like the lines and AB.
The lines on AB, what do you mean?
Like
Like right here,
the
so?
symbol that you put to represent like where?
Like right here, so if we say the modulus of U and like say the modulus of B,
Yeah, yeah, yeah.
the reason why I didn't write it is because the question didn't assign any specific name to the vector, so that's why I left them blank.
Uh,
So on your calculator, all you need to do is to find the inverse, the cos inverse of this function. So we're going to get that theta is going to be equal to 19.1 degrees. Now, when you're rounding off an angle, we always try to round off to 1 decimal point, 1 decimal place. All right, so just bear in mind for the assignments, please to um save them as a PDF and upload them in the Teams, all right? So it must be a PDF document.
All right, sir.
All right, try number 2 when you're finished.
Sir.
Go ahead, go ahead.
All of the assignments are to be done in groups, right?
No.
Uh, uh,
So when you look at the assignment, it will
which one is
give
the
you
group one?
the instruction. I think module 2, I think assignment 2 it should be the only group one. You can check and let me know. But assignment 2
Okay.
should be the only group one.
All right.
Sir, are they on Moodle?
Yeah. They're in Teams.
Eat.
He sent the documents.
What?
All right. So we should be finished.
Oh, okay.
Is that a yes or are we still working?
I thought the mouse moving, so I thought you were muted by accident. So
Yes, are we finished?
mm, not quite, sir.
All right, give you about 2 more minutes.
Uh,
All right, let us see where we're at. So we're going to get 1 times -2 plus 3 times 1 plus 2 times 2. So -2 plus 3 plus 4, we're going to end up with 5. All right, this is another 5. And then we find the magnitude. So the magnitude of OA is equal to 1 squared plus 3 squared plus 4 plus 2 squared. So this is 1 plus 9 plus 4. So this is going to be the root of 15. And then we find the magnitude of OB, which is going to be equal to -2 squared plus 1 squared plus 2 squared. So this is equal to 4 plus 1.
1 plus 9 plus 4 is 14.
14, yeah. 4 equal to the root of 9, which is equal to 3. All right, so cos of the angle is going to be equal to the product of the two vectors over the magnitude of the product of the magnitude of the two vectors. So this is going to be equal to 5, all divided by 3 times root 14, which is going to give us 3 root 14. So that means theta is equal to cos inverse of 5 all divided by 3 root 14. All right. So cos of 5 all divided by 3 root 14. So we get that theta is equal to 63.5 degrees. Did you guys get that?
Sir,
Yes.
why did you do the square root for 9 but not 14?
All right, because the square root 9 is a perfect squared number. Because when
Okay.
you find the square root of 9, you get 3, but 14 is not a perfect squared number. If I find the square root of 14, I'm going to get a decimal number. So I'll just keep it as is. Yeah.
Okay.
And it's stuck.
But sir, if you didn't, you would still get the same answer.
Yes, because if you have root 9 times root 14, you should get the same answer same way.
Okay, sir.
Amen. I want you to give number one a try. So even without us going through it, by reading the definition and look at what the definition is saying, you should be able to do it. So go ahead and give it a try, please.
All right, sir.
All right, we got that answer, yes?
Okay.
Yes, sir.
All right, try this question for me, please.
Uh, sir. Hello.
Yeah, man, go ahead.
Yeah, some people
Go again.
because they some classmates are asking to be added to the teams.
Yeah, I say.
Yeah. I'll just send. Should I just send mails in the chat or?
Yeah, just send your emails in the chat. Thank you.
Alright.
Yeah, the current email that they use from VTDI. Thank you.
Gotcha.
Oh yeah, okay.
Like, there are other people, but that's subject.
Oh, okay.
All right, so why are we writing 10 right here? Is because the question say when the length of the vector AB is 10. So the length of the vector is the same thing as the magnitude of the vector. What we're saying is that if we should find the magnitude of AB, it should be equal to 10. So all of this right here, so which is under the square root, once we find the square root of it, it must be equal to 10. That is what they're saying. So to solve this, all we have to do is to square both sides because we need to get rid of the square root. So we're going to get 100 is equal to 38 minus 4x plus x squared. Get it into a quadratic. So we're going to get 0 is equal to 38 minus 100 minus 4x plus x squared. And so we're going to get 0 is equal to 62, negative 62 minus 4x plus x squared. Now what we can do here is to use the quadratic formula to solve this and see what we get for the answer. So A is equal to 1, B is equal to negative 4, C is equal to negative 62. So x is equal to the negative of b plus or minus the square root of b squared minus 4ac all divided by 2 times a. So this is going to be the negative of negative 4 plus or minus the square root of negative 4 squared minus 4 times a times c all divided by 2a, 2 times 1. So we're going to get 4, negative of the negative gives us a positive, plus or minus the square root of 16. And 4 times 62, the negative times the negative gives us a positive. So we're going to get positive 248, all divided by 2. So remember now we're solving for x. All right, so this is x is going to equal to 4 plus or minus the square root of 264. So this is 264 all divided by 2. So the square root of 264 is going to give us 16. Let me take it over here. So x is equal to 4 plus or minus 16.24 all divided by 2. So it's either x is equal to 4 plus 16.24 divided by 2 or x is equal to 4 minus 16.24 divided by 2. So x is equal to 20.24 over 2, or x is equal to negative 12.24 over 2. So x is equal to 10.12, or x is equal to negative 6.12. So those are the values that we would get for x. Now bear in mind, these are an approximated value, right? And notice these values does not represent the length of the vector. It's just the value of x that will help us to get a value of 10 for the length of the vector. All right. So as I mentioned, we're gonna stop with this question today. Focus on the assignment to get them done. Please to watch the recording on trigonometry in your teams. So when you go and for the persons who are going to be added, watch the recording on trigonometry. All right. And then all you have to do now is just take your time and prepare yourself for the assessment. All right. What I'm going to do, I'm going to look for a previous past paper and post it in the Teams as well, so you can have access to it. All right.
All right, sir.
Yeah, man. And you say you did send the names of the persons in the Teams, right?
Yeah, to send to.
Okay. All right. Thank you very much. All right, guys. Take care of yourself until we meet again. I'll be there.